All right, so for this section, we're going to, excuse me, we're going to work on exponential functions. And we're going to graph exponential functions and also graph them when using transformations. So by graphing exponential functions, we're going to talk about the graphs themselves. Where are the asymptotes? What's the domain? What is the range? And what does the end behavior look like? So let's get started with this particular example that I've got here. So it says that graph and describe the transformations for f of x is equal to -1 times 2 raised to the x minus 1 plus 3. So again, remember that for an exponential function, it means that we have our exponent is going to be the variable. So for me to go ahead and graph this, what I need to do is just set up my xy table and start picking some values. All right, so actually I'll call it x and f of x. So now if I go through and I start substituting values in here, I'm going to start with a positive value. We'll just start with, let's start with 0 for kicks. So now 0 minus 1 is going to give me a -1 for an exponent. -1 is an exponent. I have 2 to the -1. Remember that a negative exponent means I need to reciprocate the base. So in this case, my 2 becomes 1/2. 1/2 times -1 is going to give me -1/2. -1/2 plus 3, that will give me 2.5. So now let's use 1. So if I substitute a 1 in here, 1 minus 1 is 0 as an exponent. 2 to the 0 power is 1. -1 times 1 is going to be -1. -1 plus 3 is going to give me a positive 2. So let's substitute 2 in here. So then 2 minus 1, well, 2 minus 1, that's going to give me 1 as an exponent. So then 2 is the number that comes here. -1 times 2, that's going to be -2 plus 3, that's going to be 1. Put a 3 in here. All right, and you're going to start to see our pattern here. So if I substitute a 3 in here, 3 minus 1, that's an exponent of 2. So now I have 2 squared, that's 4. 4 times -1, that gives me -4. -4 plus 3, that gives me -1. We'll go just one more. Let's just go with 4. 4 minus 1, that gives me 3. 2 to the third power is 8. This will give me -8. -8 plus 3 is -5. All right, so let's plot our point. So if I'm at 0 on the x, then I'm at 2.5, which is kind of hard for me to see the way that this is set up on my screen. At 1, which is the halfway point, I'm here at 2. At 2, I'm here at 1. 3, I am at -1, so I'm dropping kind of rapidly, so it looks like it's about there is -1. And then at 4, I'm at -5, which looks to be about there. All right, now if I continue this way, all right, you'll see that the plus 3, so first off, remember just in general, okay, if I graph an exponential function, it goes like this. All right, and from the notes that you have in our lesson, we know that we have a horizontal asymptote. All right, so we have a horizontal asymptote, and what that does then is it's going to move up and down depending upon this part. So that means we actually have, and I should be able to draw with, maybe I should be able to draw a line. Maybe not. We don't need sticky notes, so no, that's not what I'm looking for. All right, I'm not going to worry about it, but we're going to have a horizontal line that is my asymptote, and that's going to be at 3. So let me turn this pen back on, and at 3, again, forgive me if it's not quite where it needs to be. Oop, well, it dropped down there. That's not good. You get the idea, though. So now this is going to continue to curl up. So this is going to come up and it's going to get really close to that asymptote line, but it's never going to cross it. And then we're going to continue our graph down this way. as it increases, or I mean as it decreases. So let's talk about the transformations and what these mean. So we know that this negative means that it gets reflected about the x. All right, so reflect about the x axis. This 2 is just our base, so that doesn't contribute anything. This -1 here, this is the left-right shift. So this means that the graph, which would normally our parent function, in this case would be f of x is equal to 2 raised to the x power. And all of our transformations are going to come off of this, just like all the stuff that we did before. We went through and we dealt with quadratics, we dealt with cubics, square roots, and a couple other functions that we just used the same transformations. So whatever goes with the x here is our left-right. And remember that what's with the x lies. It's actually the opposite of what it says. So we're going to move in a positive direction, which is right 1 unit. And then this +3 at the end means that we move up 3 units. All right, so that's our graph. Again, I just go through, I plot my points, I substitute values of x into the function, I come up with our other values. This part right here will always tell us where our horizontal asymptote is going to go, and that's going to be part of the next slide that I show you. All right, so this was just the graphing. But now as we look here, we can really see that the asymptote line comes through right here at +3, and it won't pass that. So it will approach that value but never get there. So when talking about the asymptote, so tough with the handwriting today. So asymptote, sorry, there's only one. So there's an asymptote, it's horizontal, so horizontal means it's a y equals, and that y equals is whatever this is here. So y equals 3. The domain, if I look at the domain, it's everything moving from left to right. So this arrow continues this way, gets closer and closer to 3, but never gets there. This value, these values, as I move in the x direction, in a positive direction, these continue to go down, and they'll go down at a slower rate because they're increasing. I take that back. Time out. They're decreasing exponentially. So those values are getting larger and larger and larger. Okay. So when we talk about the domain is going to be the set of all real numbers, which we describe in interval notation as -infinity to infinity. And this is always going to be the case with anything that is an exponential. The domain is always going to be this. My range all depends on what we see here. Okay. So I start at the lowest value. I know this is going to continue, and this is going to go downward forever. So this is a -infinity. And I'm going to come back up, and I will approach +3, but I will never get there. So that means I have a restriction in my range, and it only goes to 3 but never gets there because that's where the asymptote line is. Last part is talking about end behavior. So as x approaches infinity, what does this function do? So as I continue moving along the x-axis, we see that our function is continuing to decrease, so that means our function approaches -infinity. As x approaches -infinity, what value does the function approach? So if I look, I'm coming up this way, and we said we have an asymptote line here that we never cross. So then that means if I never cross it, I'm going to get closer and closer and closer to 3, but never get there. So then again, we're using this thing with the 3, and it's going to say, all right, well then as x continues to move this way, I get closer and closer to this horizontal asymptote, which is 3, and that's also where my range ends. It goes up to 3 but doesn't go any further. Okay, so again, you have to pay attention to things like, what's in front here? What happens here? Do we move left, right? What is this? And remember, this is going to be my asymptote no matter what. All right, so I'm going to change colors here and just draw it back to show that this is always going to yield my asymptote. Okay, so this number here is always going to yield my horizontal asymptote. So you know that before you even do much of anything. If you're graphing this on your own and you see this number at the end, then you know that's where you need to draw your asymptote. Okay. All right. Hopefully these examples helped in just trying to understand graphing of exponential functions. You have to make sure that you understand the whole transformations of these, whether it be reflecting about the x-axis, reflecting about the y-axis, and it's really just a review of the types that we've already done in class with transformations. Now it's just that we're using it with a different function. So everything's still the same as to how do I go through and graph it. It's just, plot your points, take a look at what it is, but exponentials have a horizontal asymptote that you have to take into account. So I'll go back here. They have a horizontal asymptote that you need to take into account, which comes from here. Okay, and that's part of our graph. So again, thank you very much. My name is Robert Main, and pre-calculus teacher at Charahoe Regional High School. Thank you, and hopefully this was useful, helpful, and helps you to succeed. Thank you.